All right, let's dive right in. Today, we're talking about Artemis II. This is the big one, the mission that's finally taking humans back to the moon's neighborhood for the first time in over half a century. You know what's actually kind of wild to think about? For more than 50 years, every single astronaut has stayed right here in our cosmic backyard, in low Earth orbit. But with Artemis II, that long, quiet pause in deep space exploration, it's about to end, and it's going to be spectacular. But this isn't just about repeating history. The whole Artemis program has a much bigger goal in mind. As NASA puts it, this isn't about just popping over for a quick visit. It's about learning how to live and work on another world. The moon is basically the ultimate training ground for humanity's next giant leap, getting people to Mars. So who exactly are these four explorers making this historic trip? And what kind of incredible machine is going to get them there and back? Let's meet them. Here they are, the crew of Artemis II, a brand new generation of lunar pioneers. Leading the charge is Commander Reid Wiseman. We've got pilot Victor Glover at the controls. And they're joined by two amazing mission specialists, Christina Koch from NASA and Jeremy Hansen from the Canadian Space Agency. And this crew is making history in so many ways. Christina Koch will be the first woman ever to travel this far from Earth, Victor Glover will be the first person of color, and Jeremy Hansen is the first non-American to ever fly to the moon. This is so much more than just setting records. It's a huge statement that the future of space belongs to everyone. And their ride? Well, it's a beast. It's a two-part marvel of engineering. First, you've got the Space Launch System, the SLS. This is, hands down, the most powerful rocket ever built. It's the raw muscle needed to just break free of Earth's gravity. Then, you have the Orion spacecraft. That's the capsule on top. It's going to be their home, their science lab, and their lifeboat for the whole 10-day trip. You know, the real unsung hero of this whole setup is the European Service Module, or ESM. It's built by the European Space Agency, and it sits right behind the crew capsule. This thing is the powerhouse. It's not just an engine, it's the entire life support system. It provides literally everything the crew needs to survive out there. Propulsion, power, air, water, you name it. And when I say powerhouse, I mean it. Get this. The ESM has 33 separate engines. 33. There's one massive main engine, a veteran actually from the Space Shuttle program, that gives them the huge push for the big maneuvers. But then it has a whole swarm of smaller thrusters for all the fine-tuning and course corrections. It's like having both a sledgehammer and a scalpel. It gives Orion both brute force and incredible finesse. Okay, so let's break down the mission itself. We're looking at a roughly 10-day journey that's going to take these four humans from Earth on a stunning loop around the moon and then bring them home safely. So here's the basic flight plan. Day 1 is all about the launch, and then a full day of checking out all the systems in a special high Earth orbit. Then on Day 2, they hit the gas for the moon. That's followed by a 4-day coast through deep space. Day 6 is the main event, the lunar flyby. And then it's another 4-day trip home, ending with that fiery re-entry and splashdown. Now, that first 24 hours is absolutely critical. Once the SLS rocket does its job, they don't just point to the moon and go. Nope. They'll spend a full day in really high orbit, putting Orion through all its paces. They'll test everything from life support to actually flying the spacecraft manually. It's only after mission control gives the thumbs up on every single system that they'll get that final historic go to leave Earth behind. And that leads us to this heart-pounding moment, the translunar injection, or TLI. This is the big one. It's a long, powerful burn from the ESM's main engine that's basically a slingshot. It flings Orion out of Earth's gravitational pull and sets it on a perfect 4-day path to the moon. This is it. This is the point of no return. And just how far are they going? Well, at their farthest point, this crew will be over 400,000 kilometers from home. They'll actually fly thousands of kilometers past the far side of the moon, setting a brand new record for the farthest any human has ever been from planet Earth. So while Artemis II is definitely a crucial test flight, it's also packed with science. The crew is going to be running some really important experiments to help us figure out how to keep astronauts safe on those much longer missions to Mars and beyond. In a way, the astronauts themselves are the experiment. They'll be doing things like Archer, which studies how deep space messes with your sleep. They'll use immune biomarkers to see how their bodies hold up against all that radiation. They're even testing a device called Avatar, which uses human tissue to see how space affects us at the cellular level. I mean, this data is just priceless for planning our future out in the cosmos. So after this amazing trip around the moon, the crew faces their single biggest challenge: coming home. That fiery plunge back through Earth's atmosphere is without a doubt the most dangerous and technologically tricky part of the whole flight. So what's the most dangerous part of this mission? You might think it's the launch, right? The explosion and all that. But nope, it's the silent, searing heat of re-entry. They'll be coming back from the moon at speeds no human has dealt with since the Apollo era. Okay, so here's the deal. After the uncrewed Artemis I test flight, engineers saw that the heat shield had worn away more than they expected. So for Artemis II, with people on board, they had to change the game plan. And their solution is kind of wild. They're actually going to come in steeper and more directly. I know, it sounds counterintuitive, but by taking a faster plunge, the capsule spends less time in that super hot atmospheric furnace. It's like ripping off a Band-Aid, a quicker, hotter blast that is actually safer for the shield. Just imagine this. Orion is going to slam into the atmosphere in nearly 40,000 kilometers per hour. That's about 25,000 miles per hour. This will literally be the fastest crewed re-entry ever attempted. And it's going to put that new re-entry plan and that heat shield to the ultimate test. And after surviving that incredible furnace, a whole series of massive parachutes will deploy, slowing the capsule down for a gentle splashdown in the Pacific Ocean. And out there, U.S. Navy recovery teams will be waiting to bring our explorers home. So when you boil it all down, Artemis II is the final exam. It's the mission that proves the whole system, the rocket, the capsule, the ground teams can all work together to safely fly people on a round trip to the moon. A successful flight here paves the way for the very next mission, Artemis III. And that one is the landing. And that's what's so exciting. Artemis II is really just the beginning. A successful flight means humanity can go back to the moon, not just to visit, but this time, to stay. The next mission lands. And that leaves us with this incredible question to think about. What are we going to discover when we finally learn how to live on another world? The journey is just getting started.